Alright, this is section 2.2, linear relations and functions from the Algebra 2 textbook that we used the high school. What we have is what are linear equations and what are not linear equations. Mostly linear equations are a straight line. Linear, okay, it's line, so it's in the term. But here's examples of linear equations. See how I have an x and a y, there's no exponents onto it, there's no square root onto it, there's nothing strange about it, it's just x and a y, okay? So 4x minus 5y equals 16, that's 1, x equals 10, that's a linear equation. Y equals negative 2/3 times x minus 1, or y equals 1/2 x. Again, there's no exponents onto it, there's no square roots, anything like that, so that makes it a linear equation. Examples of a nonlinear equation would be 2x plus 6y squared. That squared gets rid of it. Y equals square root of x plus 2. The square root of x. This one I have x times y. That makes it not a linear equation as well. And also if I divide by like x. Okay, so if I divide anything by x, it also makes it a non-linear equation. One other thing from this section, there's two things, but the other one that I have up here is standard form. Standard form of a linear equation, it's kind of weird. We introduce it, but really we don't use it that much. It's just practice of reading a form and getting numbers from it. So it's ax plus by equals c, where a, b, and c are all integers. Examples, 3x plus 5y equals 12. A is 3, b is 5, c is 12. Basically the integers are in front of the variables. Now there is also in this section you're going to find y-intercepts and x-intercepts. I'll show you how to do that. It doesn't look like the book goes into much detail, but whenever I get to the examples, I'll explain how those work. So I'm going to erase this, and then we'll come whenever we'll do some examples after I erase it. Okay. Okay, so let's do some examples of what the notes I just went over. For 1, 2, and 3, the question states, state whether each function is a linear function. So if we're looking at it, number 1, the answer is yes. There's just x, there's no square root or exponent onto it. The thing is, it can be written as, so our answer is yes. And if we want to think about it, we can write it like this, f of x. This 5 goes to each one of those terms, so it's just x divided by 5 plus 12 divided by 5. So that would work. We're not dividing by x, so that one does work. Now, if we go to number 2, we're being divided by x here. So this is not a linear equation because x is on the bottom. So we're going to say no, x can. And our reason is we're dividing by x. And that's all you need to put there. Now number 3 says p of x equals 3x squared minus 4. We have that exponent right there again, so that makes it no, it's not a linear equation. Exponent. And that's all you really need to do for those type of questions. Now if I move on to 6 and 10. 6 and 10 are saying write each equation in standard form, then identify A, B, and C. So, if I'm looking at 6, standard form, if we remember, is AX plus BY equals C. So that means we need to get this negative 4x to the other side. So we add that to the other side, plus 4x plus 4x. That turns into 4x plus y equals negative 7. Now for our answers, we need A, B, and C. So, get out my other marker. A, the number in front of our x is 4. B, the number in front of our y is 1. And C, negative 7. Okay, so now to the next thing for number 10. Go ahead and move everything over, at least the 4x over. So we get 12y, or sorry, we get negative 4x now, plus 12y equals 8. And again, let's list out our A, B, and C. So A is -4, B is 12, and C is 8. So that's basically what they're looking for. Those problems is just rewriting them in standard form and listing them out. I think the big part of this is just getting in the habit of doing math properties with variables, to not adding and combining them. So the last step is we're going to find x and y intercepts with certain equations. So let me erase this and I'll get to that. Alright, so here is the notes to find x-intercepts and y-intercepts. For x-intercept, you let y equal 0. For y-intercept, you let x equal 0. So what these are points that cross or touch the y-axis or x-axis. So, for example, if I'm looking at a graph, here's one equation. This is the y-axis. That point right there, that's the y-intercept because it crosses the y-axis. And this point, that's an x-intercept because it crosses the x-axis. So that you see y value is 0 here, and x value is 0 here. Okay, so that's why we set those equal to 0 when we want to find them. So here's an example of how to do them. If I want to find the x-intercept first, okay, I let y equal 0. So that means 0 equals 5x plus 12. We move the 12 over. Solve for x. So x equals -5 twelfths. Okay, apparently I didn't leave myself enough room. But then if I want to find the y-intercept, I let x equal to 0. So y equals 5 times 0 plus 12. And our answer is y equals 12. How these are written out would be like this. -5/2 or -5/12, 0, and 0, 12. That's how the x and y intercepts will be written out. So let's do this one down here. Let's find the x-intercept first. So we just let y equal 0, so we get 2x. Right, 3 times 0 is 0, so we get 2x equals 12. Divide by 2, so x equals 6. And we find the y-intercept. We do the same thing, except now with x equal to 0, so 0 plus 3y equals 12. So we get 3y equals 12. And divide by 3, and we get y equals 4. So those are our intercepts if we were to do them outright. So again, this would be 6, 0, and this would be 0, 4. I think if you were to look in one of my pre-calc videos, I do an example, more detail of how to find intercepts in there, because we do it in all our math classes. Pre-calc is just added up a step. So there's how you find your x, y intercepts. Hopefully that helps with anybody on section 2.2. Okay.